This lecture is going to be about subtracting numbers. So subtracting numbers, just like adding numbers, you need to know your fact families. So I'm just going to give you a little idea of what I mean by a fact family. This is kind of a relatively new term, so some of you might not have ever heard this before. When we add 1 plus 2 and get 3, that's the same thing as adding 2 plus 1 and getting 3. That is known as the commutative property of addition. The fact that it doesn't matter which order you add two numbers in, they're still going to give you the same answer. The two numbers that you're adding, by the way, those are called add-ins. So up here I've written the word add-ins, and those add-ins are the two numbers that you're adding. And when you get the answer is called a sum. And so this add-ins can be reversed in order and it still gives you the same sum. Now, in a fact family, you get all of the addition and subtraction because addition and subtraction are inverse operations of one another. And the idea behind fact families is that it relates those addition and subtraction facts. So in the old days, you would teach subtraction by saying 1 plus what is equal to 3. And we'd maybe put a question mark in here, or we'd just leave it blank and you had to fill in those numbers. And that was testing our sums, right, to see if we got them, but it was also at the same time teaching us subtraction. And so this is the rest of the fact family. The fact that 3 minus 1 is equal to 2, that's like saying 1 plus what is equal to 3. And the fact that 3 minus 2 is equal to 1, that's the same as asking 2 plus what is equal to 3. Those are the fact families ideas, and so these are the fact families here. And in a subtraction problem, these last two parts of the fact family, we have the first number, which is called a minuend, and the second number that comes after the subtraction, which is called the subtrahend. And the answer to a subtraction problem is called a difference. And the order in subtraction does matter, right? Because if you have a certain number of things and you try to give away more than you have, you know you can't do that. And therefore we need to be very careful on the order. Now the next thing that I want to talk about is how you can break things apart so that you can give them away. So let's say I have two really long chocolate bars. They each have 10 pieces of candy in them and they're all connected together. And of these two bars, I want to give my friend 4 pieces of candy. So how would I do that? Well, if I have 2 bars of 10, so I've represented that by the expanded notation idea, right? 2 bars of 10. Then I could say, well, I could break this bar of 10 into the individual pieces, 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. So there are my 10 pieces, right? So 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and my 10th piece, right? So once I break the bar, it's all broken into pieces. Let's say it just crumbles into pieces if you break one piece off. That way you don't think, well, I could break out 4 and I could keep the other part whole. It crumbles apart. So what I've done is I've kept my one whole bar of 10, and now I have 10 one pieces, right? So I've gone from having 20 minus 4 to one group of 10, and now 10 in the ones place, minus 4. And you know from 10 I can take away 1, 2, 3, and 4, and that's going to leave me with 6 pieces, isn't it? So 10 minus 4 giving me 6, and 1 minus 0 giving me 1. And what I did right there, this idea of regrouping, and that's what this is here, regrouping, that is the idea of borrowing. And when we do it shorthand, what it looks like is we say, okay, from this 2, I'm going to take away 1, so now I have 1, and I'll put that group of 10 into the next lower place. So I just put a little 1 out here because that is one group of 10, and one group of 10 plus whatever is here makes that number that you'll see in that particular place value. And that's how we do subtraction with the borrowing. Now in addition, we had a very similar idea, right, of carrying. So borrowing is just undoing what we do in carrying, and that should make sense because addition and subtraction are inverse operations of one another. So now if I have 12 items and if I want to give somebody 15, can I do that? If you only have 12, can you give away 15? You're right, you can't do that, right? Because if you have 12, you can't give somebody 15 from 12. So what this is pointing out is that order does indeed matter. 12 minus 15 does not equal 15 minus 12. Subtraction is not commutative like addition is, and I talked about that just a little bit beforehand. So now let's go ahead and practice doing some subtraction problems. So just like in addition, we're going to line up the place values. So if I want to do 283 minus 21, I'm going to write the first number, the minuend, on top, and then I'm going to write the subtrahend underneath, lining up the place values. Now, I don't just automatically write the bigger number on top in subtraction. It has to be the minuend and the subtrahend. And then I do subtraction just like I did addition, one column at a time. So I'm going to do the ones. I have 3 ones and I'm subtracting 1. Now I have 2 ones. I have 8 ones and I'm going to subtract, or excuse me, 8 tens and I'm going to subtract 2 tens. Now I have 6 tens. I have 2 100s minus 0 100. Now I have 2 100s. Pardon me. And now I have 262. Let's move on to the next problem. 543 is the minuend, so I write that first. Subtract 29. 29 is the minuend, and the top is the minuend, bottom is the subtrahend, and now I'll be subtracting. 3 subtract 9. I can't do that. You can't go 9 minus 3. That doesn't work. You have only 3 things and you're going to take 9 away from them. This is where I have to borrow. So I'm going to go over to my tens place and I'm going to take 1 away from that. So 1 away from the tens place, that makes 3 in the tens place. And I'm going to give those 10 tens to the ones. And so all I do is write a little 1 out here, and this makes 13. Now 13 minus 9 I can do. That's 4. And then 3 minus 2 is 1, and 5 minus 0 is 5. If you like putting a 0 underneath here so you can actually see that, it's fine. And now we have our difference is 514. Finally, we have 861 subtract 97. So we line them up, ones with ones, tens with tens, hundreds with hundreds. 1 minus 7, I can't do that, and remember it's not okay to do 7 minus 1. Subtraction is not commutative. I borrow, so 6 becomes a 5. I give that one group of tens over here to the ones group, so 10 plus 1 is 11. 11 minus 7 is 4. And then 5 minus 9, I can't do 5 minus 9, so I get to borrow again. And so now I have 7 in the 100s place, and I'm going to give that one group of 100 to the tens place. So now I have 10 plus 5 tens. And so that makes 15 tens. 15 minus 9 is 6. And then 7 minus 0 is 7. And so my final answer is 764. That is the difference of 861 and 97. All right, now let's practice that with decimals. So we have the same idea. We need to line them up. So minuend first, minus, and then decimals line up. Tenths place lines up. Oops, I boo-booed. That one is not 9, that's 1. And then we borrow. So 1 minus 9, we can't do it, so we need to borrow. We'll go over to the ones place, make that 1 less, and then give that 10 ones to the tenths place. So 10 tenths plus 1/10 is 11 tenths. Now I can subtract. 11 minus 9 is 2. Decimal comes down as I pass over it. 4 minus 0 is 4. 3 minus 0 is 3. So my difference is 34 and 2 tenths. Next one, menu end, 54.273, 54 and 273 thousandths, that's how that's read, minus 5.85. And if you want the 0, it's perfectly acceptable to put in a 0. In subtraction, it's much more highly recommended than it is in addition to use those additional zeros. Now we subtract. 3 minus 0, 3. 7 minus 5, 2. 2 minus 8, I can't do it, so I'm going to borrow. So this 4 becomes a 3, and I give the 10 ones to the tenths place. Now I have 12 tenths. 12 minus 8 is 4. Decimal comes down. 3 minus 5 I can't do, so I have to borrow. And now I have a 4. That carries over here. So 13 minus 5, that's going to give me 8. And 4 minus 0 is 4. Now the last one that I want to do is I want to do a little bit of a tricky one. So we're going to do 602 minus 78. And we're going to see what happens when we do this one. So again, this one's a little bit tricky. So 602 gets written down first, minus 78. So 2 minus 8 I couldn't do, but when I go to the 0, I can't borrow from 0. There's nothing there in the tens. So this is where I have to borrow from a 2-digit number. So I'm going to look at both the 6 and the 0 as the number 60. And I'm going to say, okay, what's 1 less than 60? Well, that would be 59. And I'll take that 1 that I borrowed from the tens place, because 60 tens, that's still okay to say. I take that 1 10 that I borrowed and I put it over here. 10 plus 2 ones makes 12. And now 12 minus 8 is 4. And 9 minus 7 is 2. And 5 minus 0 is 5. And there's our difference. So that's what happens when there's a 0, when you have to borrow through, so to speak. All right, now a couple of problems for you to try on your own. So why don't you try 1.09 subtract 0.17, and then why don't you try 281 minus 39, and let's try 105 minus 98. Okay, why don't you go ahead and pause and try those out for on your own. Okay, I'm going to buzz through these quickly. 1.09, line up the decimal points. 17 here. 9 minus 7 is 2. I can't subtract here, so I'm going to borrow over here. 1. 10 minus 1 is 9. Decimal point comes down. 0 minus 0 is 0. There we go. There's our answer. 92 hundredths. Now the next one, 281, subtract 39, line up the place values. 1 minus 9 I can't do. I'll borrow from the 8, making it a 7. Give it to the ones place. 11 minus 9 is 2. 7 minus 3 is 4. And 2 minus 0 is 2. Answer, 242. Finally, 105 minus 98. I can't borrow from 0, so I go all the way over. 1 less than 10 is 9. Give that over there. 15 minus 8 is 7. 9 minus 9 is 0. And so there's our difference. All right, that concludes subtraction.